higher semester you are going to study it. So this is the design criteria. So again, referring back to the manual, I'll go back to the conditions that are present. So this is the feature. There are two or three varieties of trickling filter you have to go in with. Table number 14.1 of CPHEU manual for sewerage and sewage treatment talks about design features for trickling filter: low rate, high rate and super rate trickling filter. Low rate, high rate and trickling filter. There are 5 parameters which they have mentioned as a design features: hydraulic loading, organic loading. This organic loading is the substrate that has been passed into the chamber, that is the sprinkling part of these that has been passed, right? Depth, recirculation ratio and filter media. What are the filter media? For low rate filter, rock or gravel slag are provided, rock, gravel, slag. And for high rate, synthetic materials are provided. Plastic media is for super rate. So this is how it is going to vary. Hydraulic loading is 1 to 1.4. It is a total flow including recirculation applied to that area. That means how much you are dissipating the amount of sewage into that particular tank, that will come into picture. And the organic loading is the amount of BOD present in it, biochemical oxygen demand. The amount of oxygen that is present in it to decompose the organic matter is also taken into the account. And depth is given 1.8 to 3 and recirculation ratio is 0. So this is how the table of features related to trickling filter is taken into account from CPHEO manual, that has been taken care of. So the same is been mentioned here by me with different parameter. The design step again includes, it is designed for Q average. So usually only grit chamber is designed for Q peak. Other than that, all the units are designed for Q average. So Q average is equal to this. Assume BOD. Now what is this BOD? It is the presence of the organic matter that is present in that sewage. So usually I will take for a sewage, it will be between 250 to 300. COD will be nearly 800 to 900 mg per liter. So taking that into account, I will be designing this biological unit. Organic loading is 0.8 to 1. So you have seen it is 0.08 to 0.032 or 0.32 to 0.1. So I have taken it and maintained it 0.8 to 1. So I'll take 0.8 kg. BOD at the inlet, assuming 30% of the BOD removal in the primary sedimentation tank. What I will do is, all the treatment will not be done by trickling filter as it is a biological unit. I will assume that suspended matters and some of the organic contents, 30% of the organic contents are removed in primary sedimentation tank. Taking that into assumption, I will try to design. Volume of the filter is total BOD upon organic loading, that will be in meter cube. Total BOD is BOD 5 into Q average. What is that BOD 5? It is this. Assume BOD of 250 mg. This is BOD 5. 250 I assume that you need to take. Assume depth is equal to 2 meter. Surface area is volume by depth meter square. Diameter is surface area pi by 4 d square. You will get diameter. Then check for hydraulic loading, Q average by actual area. What is this actual area? You are going to take that particular surface area that will be coming into picture. So you should get between 1 to 4 meter cube per meter square per second if it is a low rate trickling filter, or 10 to 40 for high rate trickling filter, including recirculation ratio. So this is how a trickling filter is designed. It is a very easy. You have to take some assumption of organic loading, BOD, and also you have to assume that 30% of the treatment of the organic matter is done in the sedimentation tank. You have to consider volume. Then you have to take the total BOD with its average value, assume the depth and surface area. So these are usual steps that you need to take. Then you have to consider how you are going to check the hydraulic loading, whether it is low rate or high rate. So if you come to know that you are designing for high rate, the value should be between 10 to 40 mg per liter. I have just given this note in reference to low rate trickling filter that you are going to design, because your design population is very less. If your design population is more for urban and all, you can go with high rate trickling filter. Usually, nominally, if a trickling filter is designed, it is economical one compared to that of RBC, but you need to know that for what filter rate you are going to design and what is the population. Coming to the last part of the